David Smith here with another Flipped Classroom math video. Let's get started. Today's topic, from 2 flowers to 3. This is an assignment in the Orchard Hideout unit that you're probably working through right now, and it's also the second question of the equally wet problem of the week. Okay, let's do this. So if you've read the question already, you notice that they gave you coordinate points for the 3 flowers. So I've gone ahead and graphed those coordinate points on the coordinate plane. Okay? Now what are we being asked to do? We're being asked to find the location where we could put a sprinkler that would be equidistant from all 3 flowers. We want the flowers to get the same amount of water, so we have to find the place where we can put the sprinkler where that will happen. Okay? So if you're just starting this problem, I would urge you to pause the video and think about it. Think about perpendicular bisectors and how you might use them to solve the problem. Okay, if you pause the video, let's see how you did. Okay? Now, before we get into my solution, I want to acknowledge that there's a lot of ways to solve this, lots of geometry that you can use depending on properties of figures and things like that. I'm going to use the perpendicular bisector method that we used in the only 2 flowers problem because that's kind of the way that this curriculum is leading us through. Okay? So, first off, we notice that these 3 points make a triangle. So I'm going to go ahead and draw that triangle. Okay, and then also, just as an aside, let's notice some things about this triangle. The x-coordinate of these 2 points is the same, that's 4, so this is a vertical line. The y-coordinate of these 2 points is 2, so that makes that a perfectly horizontal line. So we can add in the fact that this is a right angle, and that makes this a right triangle. That understanding is not necessary to solve this problem, but when you're doing geometry, it's good to know the territory that you're working inside of. Okay? So, this problem builds from the only 2 flowers problem. So to remind you of that one, we had 2 flowers that were pre-placed, and we needed to find the location for sprinklers that would water both those flowers equally. Or to use geometry, we needed to find where we could locate a point that would be equidistant from the 2 points. Okay, so we're going to start with that. There's a segment connecting these 2 points. We want to create the perpendicular bisector for that segment. I'm just going to sketch it in there. So it's perpendicular. I drew my right angle. I put 2 tick marks to indicate that this segment equals that segment. So that tells us that it has bisected the segment connecting these 2 flowers. Okay? So this line represents all the places that we could put a sprinkler that would be the same distance away from these 2 flowers. In geometry, this line represents all the points that are equidistant from these 2 points. Okay? If you're having trouble understanding that, you want to back up the video or review your notes because this understanding is essential for understanding this problem. Okay? So now we know where we could put a sprinkler and it's going to water these 2 flowers equally. Great, but we're not done. What about this flower up here? It needs to also be watered equally. So we're just going to take this concept and apply it again to that problem. Okay? So now we need to find the perpendicular bisector of that segment. I'm going to sketch it in here. My drawing might not be super accurate, but it should illustrate the important points. Okay, so now I've marked my perpendicular bisector. It's cut this segment in 2. So now I use 2 tick marks there to indicate that this equals that. And I put my right angle on there to say that this line is perpendicular. Okay? So now I know this line shows us all the points that are same distance away from these 2 endpoints. And I bet you, some of you back at home there are now hollering, I know the answer, I know the answer. You probably do. Let's take a look. These 2 bisectors happen to intersect at that point. So that's our solution. This point is at the same time equidistant from these 2 flowers and equidistant from these 2 flowers. So that's our solution. We figured out where to put the sprinkler. Now, unlike with the 2 flowers problem, which had infinite solutions, this one has only one solution. Okay? So there's really only one place to put that sprinkler. Now there's some interesting things to pull out here. if you're thinking that this point is the midpoint of this segment, you are correct. I use my 3 tick marks to indicate that. Okay? So that makes sense. It needs to be there because this point has to be equidistant from that one and from that one. It's not necessary to state that because we already got there with the first 2 bisectors. Now, you're wondering, well, what about bisecting that third side? Well, guess what? That's the midpoint. The bisector is going to go right through that midpoint, and it's just going to confirm what we already know. Okay? Now, there's more things to think about with this, and I'll pose those questions for you. Does this work with any triangle? Okay, think about that. Also, does it work with any 3 points? Think about that. Perhaps we'll cover those in a later video. When I first shot this video, I forgot one important component. So before I move on, pause the video and see if you can figure out what I forgot. Okay, let's see what you got. The problem asked us to find the point where we can put that sprinkler so that it's equidistant from all 3 other points, which we did on the graph. However, we can take that one step further. What is that point? Remember, we started with coordinate points for each of the corners. So if you do that, you can work out what the coordinates of that point are, and they end up being the point 9, 5. Okay? Thanks for watching, and if you enjoyed, please give me a like down below. You can even subscribe if you'd like.